Hi sir, good day. We are the group 3 and now we were presenting about the multiple regression analysis. Multiple regression analysis is very similar to linear regression analysis in which linear regression only use um, one independent variable and able to predict the dependent variable. And here in multiple regression analysis, um, we will use two or more independent variable to predict the one dependent variable. And these are my group mates, Hana Marie Arante, Harvey J. Guinto, Arlian Mamugay, Rian Obenieta, Twinnie Pahayac, and me, Gabriela Santana. So as always, let's start out with the problem and we were gonna use dataset. And this example is called Regional Delivery Services. Let's assume that you are a small business owner for Regional Delivery Services or RDS who offers same-day delivery for letters, packages, and other small cargo. You are able to use Google Maps to group individual deliveries into one trip to reduce time and fuel. Therefore, some trips will have more than one delivery. As the owner, you would like to be able to estimate how long a delivery will take based on two factors. One, the distance of the trip miles, and two, number of deliveries that must be made during the trip. To conduct the analysis, we will take random sample of 10 past trips and record three pieces of information for each trip. First, the total miles traveled. Second, number of deliveries. And the third, total travel time in hours in which what we are trying to predict. So we have there the table in which we have x1, which represents the miles traveled, x2, number of deliveries, and y, travel time. We have the in miles traveled we have 89, and number of deliveries are 4 and 7 for travel time. And the second is the 66 miles traveled, number delivery is 1 and travel time is 5.4. Here are the 10 random samples. Uh, Now remember that in this case, we would like to be able to predict the total travel time using both miles traveled and number of delivery each trip. So the question is that in what way does travel time depend on the first two measures? And the travel time here in the third column, the last column, is represent in which represent the y, and that is our dependent variable, and we will use the independent variables of miles traveled, number of deliveries, or x1 and x2. So there's one note here that some prefer predictor variables and responses variable instead of dependent variable, dependent and independent variable respectively. Since that most statistics textbooks uses dependent and independent variable, we were going to stick with that. To continue, at this slide, we can clearly define the difference between linear regression and multiple regression. So, simple linear regression is 1 to 1 or one independent variable to one dependent variable. And multiple regression is many to one or two or more independent variable to one dependent variable. So it is really extension that multiple regression is an extension of simple linear regression. And the next slides will be discussed by my group mates.
Adding more independent variable to a multiple regression procedure does not mean or necessarily mean the regression will be better or offer better predictions. In fact, can actually make things worse. This is called overfitting. So let's say we conduct a multiple regression procedure and our model explains 65% of the variation in the dependent variable. Adding more independent variable will explain more of the variation in the dependent variable, but it can do so under false pretenses. So adding more variables will always explain more variation, but it can open up a whole problem that we definitely want to avoid. The idea is to pick the best variable for the model. So not only are the independent variable potentially related to the dependent variable, they are also potentially related to each other. Now, When this happens, it is called multicollinearity. So it's called multicollinearity when the independent variable are correlated with each other. And just keep in mind that the idea is for the independent variable to be correlated with the dependent variable but not with each other. Because of multicollinearity and overfitting, there is a fair amount of prep work to do before conducting multiple regression analysis.
As we talked about before, adding more independent variables create more relationships among all the variables. So we have this many to one relationship. Now in our problem, we have a dependent variable that is the travel time. We are trying to predict the travel time of these trips. Now we are utilizing two independent variables that we selected. We have miles traveled, that is our x1, and then we had the number of deliveries or non-deliveries, which is our x2. Now we'd like to utilize those two independent variables to make prediction about the dependent variable. Now by setting it up, this way we also create a third relationship, and that is the relationship between two independent variables themselves. So we don't have just two relationship, independent and dependent. We now have a relationship between independence, and having that relationship set up the potential multicollinearity risk. So we're gonna have to see when we do this problem whether or not these two independent variables are correlated with each other. And the easy way to think about this is that if these two independent variables are related to each other, we're really not sure which one is explaining the variation in the dependent variable. So if I put sea salt and table salt in my dinner, all I know is that it tastes salty. But I can't tell the difference necessarily between the two because they are both salt. They have the same relationship. So we want to have a distinction between the independent variables so that it explains something different. We have a different relationship with a dependent variable over here on the right. So we will walk through that analysis as we go forward. Now, let's look at this situation. So here we have one dependent variable and four independent variables. So we know we have the four relationship with each independent variables and the dependent variable. So right there, we already have four variable relationships, but we are not done. We have to account for all the relationship between the independent variables, and that's six more. So now, with four independent variables and one dependent variable, we have 10 relationship we have to consider. Now you can see as each independent variable is added, this relationship become very numerous. So part of the art of multiple regression is deciding which independent variables make the cut and which do not. And we talk about that as we go, of course. So the bottom line is that some independent variables or sets of independent variables are better at predicting the independent variables than others. And some independent variable contribute nothing. So we'll have to decide which independent variable to include in our model and which one to exclude. So again, the idea is for all of the independent variables to be correlated with the dependent variable. So the orange lines, but not with each other, so the color dotted lines here.
Next would be the multiple regression model. It allows us to predict the values of the dependent variables based on the values of the independent variable. So this can be useful in various fields. So in getting this multiple regression model, we have this formula presented on the screen. The y is the independent variable, and that variable is mo atong gusto i-predict. The BO stands for the intercept, the B1 and the B2 are the coefficient, that is the estimated impact of each independent variables on y. The x1 and the x2 are the independent variables, and the E there is the term error. It is the difference between the predicted value and the actual value of y. So the term linear parameter refers to the coefficient that represent the estimated impact of each independent variables on the dependent variables. So next is the multiple regression equation. We have the formula presented on the screen. To use this, we would substitute the values of the independent variable into the equation along with the estimated coefficient to calculate the predicted value of the dependent variables. And lastly is the estimated multiple regression model. So the formula is also presented on the screen. Same lang gihapon siya sa multiple regression equation, but on this side, we have the estimated value of the dependent variable. So to sum up, the multiple regression model provides the conceptual framework to analyze the relationship between variables, while the multiple regression equation represents the mathematical expression of the relationship, and the estimated regression equation is a specific equation derived from the data to predict the dependent variable based on the estimated coefficient.
So next is the multiple regression equation where y hat is the predicted value of the dependent variable. So this helps to forecast something using the historical or present data. Okay, this topic was actually tackled before on Unit 2. So the estimated multiple regression example of this is sales, where where with the use of the given data, we can predict or forecast the sales for the following year. The beta note plus beta 1 time x1 and the following are the independent variable where it affects the y, which is the dependent variable.
Good day everyone, my name is Hannah Marie Arante and I will be the one who will be reporting about interpreting coefficient in multiple regression. So, saan nga ba nato pag-interpret sa multiple regression? In interpreting coefficient in multiple regression, it's a little bit different than simple linear regression. Where, as you can see in our example, y hat is equal to 27 plus 9x1 plus 12x2, meaning x1 is equal to capital investment, x2 is marketing expenditures, and y hat is predicted sales. The money na tanan ni sila is in thousand, which is means 27,000, 9,000, o $12,000. In multiple regression, each coefficient, which is ang 9 and 12, is interpreted as the estimated change in y corresponding to a 1-unit change in the variable when all other variables are held constant. So in this example, $9,000 is an estimated of the expected increase in sales, 9 corresponding to a $1,000 increase in the capital investment, X, when marketing expenditure X2 are held constant. But why? With the weak coefficient with our x1 variable, it is 9,000, so if we increase x1, or x is the number of 1, we have 9 times 1, or 9 times 1,000 is equal to 9,000. Assuming we hold the x2 over the right side constant, and that's how we interpret the coefficient in multiple regression. Well, another one and use the other one. What if we flip and say that $12,000 is an estimated of expected increase in sales, y corresponding to a 1,000 increase in marketing expenditures when capital investments is held constant. So, kato na, 1 unit increase when everything is being used and all the other variables are held constant, and that's how the basic idea of full regression. So now we review all of the topics that we discussed for today's lesson. Number 1, in multiple regression, it is an extension of simple linear regression. Number two, we also talk about two or more independent variables are used to predict or explain the variance in one dependent variable. Number three, we also talk about two problems may arise about multiple regression, which is overfitting, which is can be caused by adding too many variable with independent variable. They account for more variance but added nothing to the variables. And multicollinearity happens when some or all of the independent variables are correlated in each other. Lastly, is in multiple regression, each coefficient is interpreted as the estimated change in y corresponding to one unit change in a variable when all other variables are held constant. That's all. Thank you.